knows Dave Williams, but coming to us as the president of ASM International, and he's going to talk about materials and manufacturing under the from NASA. Yes, I want to say a few words. Many of us have relations today. Some of us, like Laura told me today, she looked at you. You hired me and hoping on the same day. Yes. I'll just give you like across the piece. They came from the UK after graduating from University. He went through different ranks as a professor, chairman, VP for research, and then he moved south to Alabama to Hampshire. And then we went where he was running the now we are working in the capacity of ASM.
Thank you, Voyager. Thank you all for coming. I think viewers did not share. Yes, thank you all for coming. I really appreciate it. I was saying this is the biggest room I've talked in a long, long while, and I hope you can hear me. I should say a few words about ASM International and for the students here who are part of the Materials Advantage chapter. That ASM is the largest materials professional society in the world. It is about 75% industry, 25% academic, national, and so on. And in that sense, is different to most of the other materials-oriented professional societies. And that brings with it both the challenge of getting the students interested, but also the opportunities for the students to network through the Materials Advantage chapter, but also through Lehigh Valley chapter meetings to meet people from industry. And so I thank the students who have come, and I will continue to encourage you to come to ASM meetings and meet people from industry, because most of you will not end up like me and many of my friends here. I went to college in 1967 and then left. I never could find a job, and I suspect that most of you are much better positioned. So ASM is proud of the chapters we have, over 80 around the world, 60 in the United States, others in Europe, in Canada, in Mexico, in India, and so on. And so the international at ASM is a true reflection of the society. Like many professional societies, we are challenged with post-COVID world, the online world, and the re-emergence perhaps of full in-person meetings. And again, we are managing those changes within society. So we are the Materials Information Society. I prefer to call the Materials Knowledge Society, because P.S. Eliot said, where is the knowledge that we have lost in information? That is, some of it is actually useful, and when information is useful, and we call it knowledge. We have just revamped our website. The availability of all our material online is something that members of ASM will perhaps find useful. When I did teach here in several of the classes, I didn't have to go to the gym all semester because I was carrying which was about 23 pounds, and it was therefore pretty useful. Also stood as a stop, guaranteed cure for insomnia. And now the materials handbook is online, that is, you don't have to carry it around. If I have my phone, it's in my pocket there, you can have it on your phone. And we are moving to the point where we hope in the classes, you want to find out the properties of whatever material it is. You don't have to open the handbook or go to the shelf somewhere in the department where it used to be, it will be available for you online and immediately. So we are trying to actually live up to our tagline of the Materials Information Society, and the amount of material is online, phase diagrams through materials properties, through Pearson's, animal crystallography, and so on. It's all available to ASM members. So thank you for those of you who are ASM members, and I would encourage you to continue to support society. What I'm going to talk to you about today is, in my own experience, at least one of the most exciting projects that I've been involved with in all those years since I went to college. And I would stress that the project is about 8 months old now. So what I'm talking about is very much at the early stages. The potential upside of this is, as far as I'm concerned, just extraordinary. Because whatever one might think about the cost, the carbon footprint, and the value of going to lower orbit and beyond, it would be my belief that human beings will continue to try to discover what is beyond those boundaries, no matter what the consequences are, since we are totally bad at thinking in the long term about our own health and wellness. So while there are challenges to living and working in lower orbit and beyond, there are also advantages that come from being able to live and work in that environment, which I shall touch on briefly as I go through this presentation. The topic is Starlab. That is the name of the next space station that will be launched in 2028. The George Washington Carver Science Park. How many of you know who George Washington Carver was? That's a refreshingly good number. You will know then that he was an agronomist and that he worked to find products for former slaves who were given land post-Civil War, and peanut butter is his most famous development. And somebody who dislikes peanut butter with a vengeance. I was delighted that so many other people still do. And the major aspect, or a major aspect, of the planned work in low Earth orbit celebrates George Washington Carver's agronomy roots, and also the fact that he helped to diversify both the economy for black farmers, but also to diversify the farmers in their color. And we hope that this space station will for which you've got a good idea that this commercializable, that's something very well done. So that is the basis behind that title. And a major part of the work that we will be looking at is, as I said, the materials and manufacturing in low Earth orbit. And that's obviously what I want to emphasize tonight, given the role of ASM as both the materials and the manufacturing related production capacity. And ASM on this daily basis is already involved in this particular project. My role in here is to be responsible for the university, industry, and government interactions behind both raising the money to build Starlab, which will cost probably a couple of $1 billion as a space vehicle, and to develop a science park, which will be at the Ohio State University on about 120 acres of land given by the university. And this will be the first science park that is both on the ground and in low Earth orbit. We are already attracting companies to come and build facilities at the Carver Science Park. Companies that see a market for their products in low Earth orbit and beyond. So that's the sort of big picture. And now let me put that in context. This is the ISS, the International Space Station. If you are under 23 years old, and I certainly see some of you look that way, and you person don't, then at that age, you have never lived when every member of the human race was on Earth. We have had a continuous human presence in low Earth orbit since November 2000. In fact, a continuous American presence in low Earth orbit since 2000. If you look at that space station, it would be a compliment to Mr. Time. There's only one thing worse than faculty committee, that's a government committee, and this is a committee of governments that put this together. So that's why it looks like that. And it took 52 space shuttle launches to put all of that stuff in low Earth orbit. And so it is now close to 23 years old. And most of you are probably not driving a 22-year-old car. And most of you would not enjoy living in a place with no shower or laundry that's been hanging around for 22 years. So NASA and its wisdom has decided that space station's life should be brought to an end. The plans are to deorbit is the appropriate phrase in 2031. We hope that it is appropriately deorbited into the Pacific Ocean. The challenge that may precede that is that Russia is a major part of the space station, and Russia controls the propulsion on the International Space Station. And the United States controls the power on the International Space Station. So that is an interesting diplomatic balance that may keep the station operating for the next 8 years. So, about 18 months ago, NASA made 3 awards for commercial pre-flying space stations. One was to Northrop Grumman for defense, so we will not know what they propose to do with that. The other was to Jeff Bezos for conceptual orbital reef, which is basically whatever Jeff wants to do with it, since he has the resources to these really company, one of their major companies, or Voyager Space and Nanoracks, companies whose names you have never heard of unless you are familiar with living and working and building in low Earth orbits. And these 2 companies have been doing this for many, many years. And so the next slide shows Starlab, which will be built by Voyager Nanoracks, or designed by Voyager Nanoracks. And it is designed to be a commercial space station. That is, if you want to use it, there has to be a product that is valuable back on Earth and enhanced because of being made in space, or made in space for the continuing growth of life in low Earth orbit and beyond. At the top, on the right there, sorry, the font is very small. It is what it is. 1 launch compared to 52 launches of the International Space Station. This will be a single launch. It will go up in 2028. We hope that's the right phrase that will actually get up there. And it is designed, this is the schematic that Airbus has produced. It will be manufactured by Airbus in Germany. And the financing, as it says, will be private, and Voyager Nanoracks are already raising the money to build this. There will be the opportunity for additional modules. The design is such that if the one fills up, then you can send another one up and basically screw it in back and add solar panels, and you have 2 space stations. Alternatively, a design like this, once you have manufactured it, the sunk cost of design build is seriously reduced for the next space station. A real challenge with the International Space Station that was being designed by Kennedy, its orbit was fixed by Kennedy. Once you're in orbit and going around the Earth, you are in that orbit because the energy cost to change orbit is such that you can't carry really one. So the idea of relatively cheap going to keep space stations that have multiple different orbits is much more feasible with a single launch, single design like this. It is designed for 4 astronauts, 24/7, 365 of capacity for those space. That compares with about 8 for the International Space Station as a maximum. It is about the volume of the 747 fuselage. But remember, in low Earth orbit, there is no buckle down, so all of the space is used. There's a whole bunch of other aspects on the left side here, which goes into more detail. But the most important thing about Carver is the main university on in the whole Starlab launch. And that is we won that award over at the whole bunch of communities. For the reason that if you are looking at a serious ag bio manufacturing and materials manufacturing, you would really like a university that has the scale of both ag and engineering that any major land grant university has. And we have that agriculture is the biggest industry in the state of Ohio. And the agriculture college has faculty of 88 accountants, and there is politically both very savvy and has to be going their money out of the state. We are, again, one of the largest materials departments in the country, the manufacturing that Ohio State is approved large. So the other thing that I should note is that the lead professor on this, Professor Carver, is somebody that I've worked with for 15 years, worked with me in Huntsville when I was there, and I brought into Ohio State in 2015 at the Armstrong Chair of Aerospace Policy, the John Glenn College, and the College of Engineering. And it is his concept that he sold to Voyager Nanoracks to build a space station in partnership with Ohio State. Pre-base proposals, $15 million. I like those. We had a couple more since, a bit more before that. But what I'm saying is that John is fundamentally responsible for this. But I do take credit in working for Ohio State. So I had a hand. Next slide. A bit about the two companies. Voyager Space, as well as I can, it's a holding company. The CEO, Dylan Taylor, actually flew to low, not quite low, flew on Bezos and rocket a little while ago. So Dylan is independent of wealthy. Show how it can be $1 cost for a 5-minute flight. But if you look at the data for what Voyager Space has done in low Earth orbit, then that is an extraordinary investment in technology and people in low Earth orbit. And one of the companies is Nanoracks, the next slide. Again, Nanoracks builds stuff to go into low Earth orbit. And the picture on the far right with the Nanoracks logo on it is the Bishop Airlock, which is the first private real estate on the International Space Station. And it is a huge airlock that allows transfer of materials and large bits of stuff into and out of the space station in ways that the original design didn't allow. Again, you can see a number of payloads launched and the countries that Nanoracks use. The Voyager Nanoracks between them were a very viable pair to compete for a third of the 3 space station grants that NASA put out, as I said, about 18 years ago. There was a 4th bid from SpaceX or something like that, but they weren't successful. Next slide, please. So the various organizations that Voyager Nanoracks put together to help develop the science part, which remember will be the companies on the ground developing technologies and experiments to run in low Earth orbit on the Starlab space station, are the following that you see here. Since Technologies is up between them, they put more hardware on the International Space Station, and the preceding space stations space back in the 1970s. And anything that works up there, and something furnaces and microscopes and equipment and having that information, having that real estate made by some technologies, which have to be one of Voyager's basically holding companies. University Space Research Association is exactly what it says, based out of NASA land, also in Ohio, I should say it was outside NASA land. Ohio State, again, in Ohio. So Ohio has a strong vested influence in this whole science problem. And that is important about the next phase of what we call the terrestrial analog facility. I'll get back to that in a little while. We are part of the International Association of Science, also the ASM. DreamUp, a company again you've never heard of. DreamUp is a Voyager space company, not surprisingly. They have put over 400 payloads into space from K through 12 schools around the world. So Voyager is serious when it says that anybody with a good idea will have access to the Starlab space station, and not just the diversity of reflecting George Washington Carver's leadership, diversity of age and of schools from anywhere, not just schools that can afford it. And the last part of their Starlab Oasis also comes for the space company. Starlab Oasis is in the United Arab Emirates and co-funded by the sovereign wealth of UAE. And UAE has the money to plan how it can exist once the oil runs out. They have a system of government and the need to decide to plan right now for however many decades ahead that will be. They are a desert country. They are extraordinarily water limited in their ability to produce food for the nation. And so they are seriously interested through Starlab Oasis in finding ways to grow, eat, recycle, grow again, eat again, recycle again in highly water constrained environments. And there is no more highly water constrained environment than living in the lower orbit, where every drop counts, because the price of finding it up there is still rather extraordinary. So they are too a major driver on the economy side of the Starlab operation. I want to now talk about the, which is the Terrestrial Analog Facility. If you've ever been to Houston and you go to the Johnson Space Flight Center, there is a mock-up there of various parts of the International Space Station where experiments can be done before they go to the International Space Station. Get to Huntsville, Alabama, there were mock-ups there of the space shuttle where you could run experiments on the space shuttle before you went up on the space shuttle. And what we are planning at Ohio State is to house the Terrestrial Analog Facility for Starlab. That is a fully working model of the space station, reproducing exactly the environment that will be in lower orbit, apart from gravity and apart from the radiation flux, atmosphere, vacuum, stuff like that. And that Terrestrial Analog Facility was decided only 7 months ago to be housed at Ohio State University. And that has transformed our relationship with Voyager Nanoracks and transformed Central Ohio's view that suddenly it could well be the focus of human spaceflight operations in 2028, because no longer will astronauts be trained in use. Because there's going to be no International Space Station. Astronaut training will take place at Ohio State University in the for experiments. We'll go through that Ohio State, and it will be at Carver Airport. Three research universities that own and operate our own airport, And the area you see, the green area at the top, which is about half a mile from my golf course, which is the other green area, has been basically loaned at a very generous rate to Voyager Nanoracks to build the Terrestrial Analog Facility in 10 acres and to allow another 120 acres to build the science park. And we're currently working with various capital developers and design work companies to raise their money for that science park, which will probably be over $100 million to actually build it. And to get Voyager Space to decide to put this TAF at Ohio State, it was an open bid, and the competition was Denver, Huntsville, and Houston. And we won. Houston, you have a problem. How do we do that? The university has received, as a $60 million out of a $1 billion fund. This is not the university research operation. This is an economic development operation. And so we had to engage the state of Ohio, and that started with the governor's office. And Chuck, who's the lieutenant governor, is in charge of the technical development aspects of the state government. The Columbus region, that is the central region of Ohio, and the counties, Franklin County, where we are here. We attract companies to Central Ohio. And Jobs Ohio is the public-private partnership the state has put in place to provide the money for the Columbus region and the state government to attract companies. And before we won the Starlab, the previous major win was to get Intel to decide to build a $20 billion. While that may seem far bigger and better, and there's certainly a lot of money out of the state for it, if you look at the workforce in Houston currently supporting the International Space Station, built up over well over 30 years, it is 11,000 people. So the opportunity, if this goes well, to build a whole new economy for research, commercialization in low Earth orbit, will be thousands of jobs. And that's the excitement that this team found. Again, we had to involve many aspects of the Central Ohio business community, as you can see here, and also Coast Ohio, which is the center of science and industry, one of the largest science museums, one of the biggest science fairs in the country, with tremendous ties to NASA and K-12 education with NASA. But all of that's tied in to the fact that on that little bit of land at the top there, we hope in 10 years' time, there will be fully working models of more space stations and 100 or more companies all feeding into that process. Next slide. We have engaged various industries in addition to all the ones that I talked about on the left, who are actually taking the design and building it, as I mentioned, Zinn and all the others. We have engaged a whole bunch of industries. There are many others in those listed there, but let me just mention AWS, Amazon Web Services, who we are working with to develop both the cloud computing in low Earth orbit and secure quantum communications between low Earth orbit and the ground facility. Because with a commercial space station, Company X that is developing its products in low Earth orbit, 2 feet away from Company Y, maybe a competitor, wants to ensure that their work is totally secure and their communications with our result are totally secure. Unlike NASA with civilian space, where the communications with the space station are totally insecure and are open to the public to listen to. So we're working with AWS on that. Thermo Fisher, the nation, in fact, the world's largest computer scientific instrumentation, we are working with to see if they will be prepared to be the sole provider of scientific instrumentation in low Earth orbit. What's driving Thermo Fisher? these days is first of all remote operation, artificial intelligence, now human interface kind of stuff, and also compact design. So the smaller, the more robotic, and the smarter your technical instruments are, the more you can sell, the easier they are to operate, and the more robust the results. And where better place, or better place, to design and build in highly constrained space, working scientific instruments that are doing it in low Earth orbit. And most interesting is both a week after we were announced as the site of the Terrestrial Analog Facility, both of them announced their partnership with Voyager Space to build the astronaut accommodations in low Earth orbit. Why might those do that? Well, first of all, Conrad back in the 50s, he always wanted to know something. Now he's going to get one. And for another point, I'm sure you can get some proof. Other things to get it up. Why are they interested? As I mentioned, the life in low Earth orbit without showers or laundry is really challenging. And Milton is extraordinarily interested in how to maintain a healthy and a clean environment with a minimum of water, with a minimum of detergent, and with a minimum of human interaction. Why? Because all of that goes to their whole mind. You see it already, you say, I'll save the environment, save the environment. And we are also looking at and there is a whole bunch of international companies, both in Japan, the UK, and also in the US, that are working with us. So again, all of this is about all I would say is there's a lot of opportunities for anybody who wants to join. Next slide. Just some of the universities we have engaged with already. The driving force for this is, first of all, anybody who asks is welcome to join us because we don't know how to do what we're meant to do, that is build a science park in space and on the ground. Next slide. So let me, as I will come to the end, tell you a little bit about materials and manufacturing. Things we do on the materials side. One is, as you can see, create materials in low Earth orbit that have intrinsic value because they can't be made on Earth, but when they come back to Earth, they can be sold for extraordinary amounts of money. And that generally refers to biopharmaceutical industry, which is, again, extraordinarily interested in developing RNA or other specialized protein structures that will create different structures in microgravity or different structures under the influence of solar radiation that they can produce on Earth. I don't think that we are going to produce new alloys in low Earth orbit in the absence of gravity that will have such value that when we pay the money to set it up and bring it down and sell for a price that will offset the actual cost. But the ability to build structures in low Earth orbit that can't be built on Earth or launched on Earth is a whole different side of materials and manufacturing. A bit more about that in a while. So the next slide. This has been going on for a while, and any of you who have been at Lehigh for long enough will know that here in the Electron Polymers lab will produce the first fundamentally new materials that could not be made on Earth in low Earth orbit, brought back to low Earth orbit and sold by the International Bureau of Standards for an extraordinary amount of money, lots of time in your particles. You sprinkle on your SCM specimen, and you knew exactly the scale of that was in the days before microscope. These emulsion polymers on the left, it shows the size range produced because of sedimentation, convection, the presence, the effect of gravity on the polarization process, and the emulsion polymers produced in low Earth orbit on the right. One of this is to a fault. certain they were specified by NBS at one time as a standard reference material. So, first manufacturing in the world back in '84. Nothing like that has been produced since, I would hasten to add. Next slide. Made in space has been a additive manufacturing machine on the space station since about 2015. And made in space, a company formed, as you see, 30 years ago. And one of the key founders, my side, happens to be an engineering alum. We have the ability to control that additive manufacturing machine from our campus. Red wire rolled out, made in space a little while ago. Next slide. Talks about red wire. They are building a satellite that will be able to manufacture solar panels and deploy them in low Earth orbit. And the idea behind this satellite is to show a proof of concept that you can manufacture large solar arrays in low Earth orbit. Next slide. There are several companies that have in fact spent tens, if not hundreds of millions of dollars on attempts to improve their products while flying the International Space Station. Procter & Gamble, as you can see, has the Thai logo on the International Space Station National Lab. Estee Lauder was really looking at its beauty products and the fragrances and the effect of manufacturing fragrances in microgravity. Colgate Palmolive doing the same with its beauty products. And my favorite is checking out the flavonoids in the distillation process and how the presence of gravity or otherwise affects the quality of the single malt. And I somehow doubt that you get the cost of that. Nevertheless, there are companies out there that are interested in manufacturing locally. Next slide. There is a national lab on the International Space Station. It is looking at advanced materials manufacturing products, as you can see here. Much of it coming out of NASA in Cleveland. And again, to our knowledge, nothing has been produced. Next slide. There is competition. Yangon is China's space station up there already. And quote from the South China Morning Post a few months ago, which reminds us that commercial use of low Earth orbit is only one aspect of the use of low Earth orbit in terms of the high ground. And then the recent one also is building a space station effects in mind. So as always, the challenge of managing space has both the international volume results in some of the challenges that we see. Next slide. McKinsey as always produced a report, like all the McKinsey reports, lower the which and they came up last June with what I've already mentioned, that we're seeing so it's good to know that we read out McKinsey report. Next slide. Let me tell you what we're doing. I know I understand to help generate manufacturing in low volumes. The various universities listed at the bottom right there. It took most of me 2 years to writing most of them. The concept of this is technology in low Earth orbit. We have done, as I mentioned, additive manufacturing in low Earth orbit, but the ability to forge low Earth orbit is so far unproven. This is the concept of which we proposed a couple of years ago. On the left is the forge, which has the ability to beat, and stretch, and then pull and squeeze materials in lower orbit, and many other places. Various schematics shown on the left here, and I stress this in our 2 years old, shows the opportunity to design any piece anywhere. So if your plane happens to run out of breaks from rather important piece in somewhere where there is no supply chain, the idea would be that you manufacture a piece wherever you are. Aircraft carrier, the second one, again, often in remote areas without the appropriate supply chain. Further, operating our center of design and manufacturing works with our surgeons to reduce additive manufactured parts for replacement during facial reconstruction, where the design of the part is sent to the center at the start of the operation, and the piece is implanted before the anesthetic of more go. So the idea of immediate manufacturing of a specific chain for a specific need is what this has been talking about. We do additively the idea that we can explore the range of materials that we can use beyond additive manufacturing. Unfortunately for us, they put in the lower orbit bit in slide number 4, so we were able to use this to convince Voyager that we were indeed well ahead of Houston and others, because we'd already thought about the challenge of making stuff in lower orbit. So the next, that's okay. The next thing we would have to do is join stuff in lower orbit. We can additively manufacture it, we can heat it and beat it. If we can join additively manufactured pieces to heated and beaten materials, or beaten, I should say, then truly we have the opportunity to build structures in lower orbit. The idea, for example, we could build 100 meter by 100 meter solar array. Why not? Because there's no gravity. You can send this array of the tubes out as long as you want. It doesn't sort of sag at the end because there's no gravity. So you can build structures in lower orbit. You can't build on Earth because of gravity. And you can't launch them if you do. So our welding engineering group has another NSF manufacturing materials joining innovation center this magic. And they're working with NASA at the various Marshall, Langley, and Glenn research centers on an interdisciplinary capstone project designed by students to do welding in lower orbit. And the next slide shows the prototype design, a little bit large for lower orbit, but we will be flying this on the appropriate aim vomit comets, putting the parallel loose, giving you about 35 seconds of microgravity, perhaps about 45 seconds of one-fifth gravity if you're going to be a bit longer than gravity on Mars. So the idea here is that we are learning how to do manufacturing lower orbit. The challenge with welding, of course, is that when you weld here, particularly if you produce molten metal, which you don't always have to do, is that you know where the molten metal is going to go if you set your welding rate. Unfortunately, that's simply because of gravity. And so the last thing you particularly want in lower orbit is molten metal flying around those and getting away. There's a very similar problem for doing surgery. We're working with for lost surgery now because you would go spend more time building on the moment comment practice surgery in lower orbit and beyond. ultimately, if we don't live there, we have to eat. Remember, going back to Lord Washington Carver, we have to be able to build stuff, which is what we're looking at here, and we have to be able to stay alive. The accessibility, particularly when we get beyond low Earth orbit, to operate on astronauts is seriously reduced. And so George will be finding ways to carry out operations where he manages to work out where the blood is going to go, which is a very similar problem for where the molten metal is going to go, and where you actually try the arc, or however you shoot the world the material. So we're working with George to build on his knowledge of surgery in microgravity to do the same with welding in microgravity. Next slide. That's it. Thank you very much for listening. We're just getting started, and it's going to be really fun. If you've got any ideas, come and see me. Thank you.